All right, let's be real. If you've ever built an Android app, you've probably felt that sinking feeling when it starts to feel sluggish or just laggy. Well, today we're diving into a high-performance playbook designed to turn those clunky apps into the kind of smooth, fluid experiences users absolutely expect. But first, we need to understand the real enemy we're up against.
And this quote, man, it just cuts right to the heart of it, doesn't it? That dreaded application not responding dialog, the ANR, that's not the start of the problem. That's the tombstone. It's the final catastrophic failure. The real damage, the thing that makes users uninstall your app, happens in those seconds of stutter and unresponsiveness leading up to it. So, what is an ANR, really? Well, think of it this way. Your app's user interface, every button, every scroll, everything the user sees and touches, it all runs on a single, super important channel. We call it the main UI thread. And if that thread gets bogged down with some heavy task for, say, more than 5 seconds, the whole app just freezes solid. It can't respond to anything. That's an ANR, and that's our #1 target for elimination. To solve this crisis, we have to put on our detective hats. We need to unmask the usual suspects, the common culprits behind all these performance nightmares. And listen, it's usually not just one single thing, but a few key villains working together to just ruin the user experience.
And here is public enemy #1, the most common and honestly the most destructive villain of them all, the blocked UI thread. I want you to imagine a single-lane highway. The UI thread is that one lane, and every tap, every swipe is a car. Now what happens if one car just stops in the middle of the road to do some heavy lifting, like, I don't know, making a network call or running a big database query? You get a massive traffic jam, right? Nothing else can get through. That is exactly what's happening inside your app.
Now this slide, this is the aha moment for so many developers because it just lays out the danger zones so clearly. Just look at the table. The only thing that belongs on the main UI thread is updating the UI. That's it. Everything else, from network calls, which carry an extreme risk, to database queries and loading images, all of it has to be moved to a background thread. This isn't a suggestion, folks. For a fluid app, this is non-negotiable.
Okay, our second culprit is a little more subtle. It's inefficient rendering. You see, even if your UI thread isn't totally blocked, a slow rendering engine can cause what we call jank or stutter. This is what happens when your app can't draw a new frame every 16 milliseconds to keep up with the screen's refresh rate. Legacy rendering engines especially can really struggle here, and you end up with dropped frames and a UI that just feels choppy and wrong. And finally, we have the silent killer, poor memory management. When your app has memory leaks, meaning it's holding on to things it doesn't need anymore, the system's garbage collector has to work overtime to clean up the mess. And these garbage collection events, well, they can cause these long pauses where your entire app just freezes while the system frantically tries to find some free memory.
And don't think this is some minor issue. This number is absolutely staggering. In long-running app sessions, memory leaks are responsible for about 80% of all ANRs. Seriously, just let that sink in for a second. As those leaks build up, the garbage collection pauses get longer and more frequent until, eventually, they freeze the app entirely. Fixing memory leaks isn't just good hygiene, it is paramount to performance.
Okay, enough with the problems. Let's talk solutions. We've diagnosed the illness, now it's time for the cure. And this isn't about little tweaks and micro-optimizations. This is about a fundamental shift in how we build. We're going to open up the high-performance playbook and build an arsenal of tools and patterns for achieving true UI fluidity.
The foundation of our entire playbook is a new graphics engine. We're ditching the legacy approach and moving to a modern powerhouse like Skia. Now, Skia isn't just some random third-party library. It's the same graphics engine that powers Google's Flutter and the Android operating system itself. What does that mean for you? It means higher efficiency, way better drawing quality, and a massive, massive leap in performance.
But you know, high-performance engineering is full of these fascinating trade-offs, and this chart illustrates one perfectly. It turns out the old legacy canvas might actually be faster at one very specific task, rendering raw images. But, and this is the crucial part, Skia's overall graphics performance can be up to 50% faster because it's optimized for what you do 99% of the time, drawing complex UIs. It's a strategic choice. You optimize for the common case, not the rare exception. Next up, we have to conquer the main thread. The strategy is simple, really. Offload all heavy work. Everything. Use modern asynchronous patterns. And then, when a background task is done, you safely send the results back to the UI thread so it can be displayed. For animations, you go a step further. You sync directly with the Android OS's own frame drawing conductor, the choreographer. This makes sure every single frame is delivered perfectly on time.
This is the secret to that buttery smooth feeling we're all chasing. Now, let's talk memory. It's so tempting. You get an out-of-memory error and you just want to flip that one switch in the manifest called large heap. This quote is a critical warning. Don't do it. It's a trap. Using a larger heap doesn't fix your memory leaks. It just gives them more room to grow. And worse, it leads to much longer garbage collection pauses, which, as we know, cause stutter and ANRRs. The real solution is to find and fix the leaks, not to ask for a bigger, leakier bucket. So here it is, a clear 5-step roadmap to optimization. Step 1, set up a modern toolchain. Step 2, migrate your rendering over to Skia. 3, overhaul your UI with high-performance components, like virtualized lists. 4, do a ruthless audit and move every single blocking operation off the main thread. And finally, Step 5, profile continuously. Because performance, it isn't a one-time fix. It's a discipline.
So after all this discipline, all this hard work, what's the payoff? Well, the result isn't just a slightly faster app. It's a complete transformation of the user experience. It's about achieving a level of performance that feels, well, truly native.
This is the goal. This is the prize. Developers who've gone down this path describe the end result as super extraordinary performance, a smooth, fluid UI with zero stutter, zero lag, and a complete and total elimination of those dreaded ANR errors. We're talking about creating an app that feels responsive, reliable, and honestly, just a joy to use.
And when you boil it all down, it comes down to one core philosophy. Modern optimization is all about adopting what you could call a native delegation mentality. It means you have to understand what the underlying Android OS is really good at, and then you leverage those strengths. It's about knowing when the abstractions of your framework are helping you, and, more importantly, when they're costing you precious milliseconds on that main thread.
So I'll leave you with this final thought. This playbook gives you the tools, but the real, lasting change comes from a shift in mindset. You have to ask yourself, when must you be willing to break the rules, to challenge the conventions of your own framework, in order to deliver an experience that isn't just functional, but is truly fluid and native class? The answer to that question? That's the key to exceptional performance.